Hello everyone, today's lesson is the properties of inverse trig functions from the trig functions. Okay, lesson 1. Let's have a look at, before we go on to the properties of all that, let's have a look at the inverse trig functions. What are they? Inverse sine function is, this is how we call it, like inverse sine, but also arc sine x. Inverse cosine function would be written like this, and then we call arc cos x, or also inverse cos x. I left all the x bits deliberately for you guys. Okay, so that's what we got. Let's have a look at inverse sine x, arc sine x. Now this is a graph that inverse functions is actually reflected about y equals x line. Okay, so as you can see, that's the line right there. The dotted line is where it's a normal y equals sine x. Okay, and we got this line going through. Do you remember inverse, like x and y coordinates will be swapped around? So before we start, actually let me explain. We need to have restricted domain because, can you see this HLT is like a horizontal line test. Now we did whether it's a function, the equation is a function or not, by using vertical line test. Now for that function to have inverse function, we need to do horizontal line test. Now if they fail, that means they don't have an inverse function. So for example, sine function is function because it actually satisfies the vertical line test. But if we draw the horizontal line test, it miserably fails, right? Because it goes more than 1. So we need to somehow make this inverse function by restricting the domain. Okay, now with that domain we need to have a maximum and minimum included. Okay, to have that, we're gonna have to cut it into pi over 2 and minus pi over 2, because if we pass it, if I go up to here, when I draw the vertical line test, it'll fail. Okay, but if I cut it here and here, any line, if I do horizontal line test, it'll be fine. So we are going to use just between minus pi over 2 to pi over 2. Okay, so it'll be pi over 2 and 1. If I reverse that, it'll be 1 and pi over 2. So it's going to be on this here. Same thing, minus pi over 2 minus 1, I reverse this one, it'll be minus 1 and minus pi over 2. When I say reverse, it's an x coordinate and y coordinates will swap around. And that's where my maximum and minimum is going to go for my inverse function. Okay, so and then that's my reflected by y equals x line. So that goes to here, that goes there, and I just follow it, and that's my inverse sine x. And so we only just looking at this area here, so I'll just sketch this again on there. Okay, and then domain will be minus 1 and 1, range will be pi over 2 to minus pi over 2, and then it's odd function, and of course that's exactly what I just told you about. Excellent. So that was the inverse cos. Let's have a look at the inverse sine. That was inverse sine. This is inverse cos and arc cos x. Also, it's reflected about y equals x line. Now this one, I'm gonna go. So dotted line is the what y equals cos x. Yeah, and that's my reflected line there. And what's gonna happen? We can't use the domain from like minus pi over 2 to pi here, because that's not really representing maximum and minimum value, isn't it? Because my minimum is here. So what we're going to do is we are going to cut 0 to pi. If I do 0 to pi, I will get both the maximum and the minimum all included. Okay, so now because my domain becomes my range for inverse function, isn't it? So I'm going to go have a 0 to pi up there, and my 0, 1 is 1, 0. Okay, 1, 0 will be here, and then my pi over 2, 0 will be 0 pi over 2 will be here, and then my pi minus 1 will be minus 1, and pi will be there. So all that is here and have to cross through here. Now if you look at this line here from here, and that's reflecting here. Okay, so if you want to, you can actually turn the page, like rotate it, somehow you will get that. So you will see it that it's actually reflecting there. And our domain is minus 1 and 1, which is same as sine, but the range is not pi over 2 to pi over minus pi over 2, it's 0 to pi, because it doesn't satisfy, we can't make it. So that's the explanation right there. It doesn't work. So we agreed to have that 0 to pi. All right, so inverse tan now, which is arc tan x. Now it looks like this. Again, the dotted one is tan x. Okay, normally it goes like that. But tan x will have asymptotes, isn't it? On the pi over 2 and minus pi over 2. That's where x equals minus pi over 2, x equals pi over 2. With the inverse, this will be y equals pi over 2, y equals minus pi over 2. That would be my asymptotes on that limit. So again, my reflected line will be y equals x there. Now that's my tan x. Now tan x is quite happy, satisfies with the horizontal line test. There's only one there whenever you go. Because of asymptotes, we're only looking at this part. So that's quite happy. So all we have to do here is we're just going to pass here, pass there, and then sketch it. So can you see what I've done here? I actually draw the y equals minus pi over 2, y equals pi over 2. That would be my asymptotes or limits of my inverse tan x. So it's not going to pass through there. It's not going to pass through here. So that's my, if it's a bit longer, it goes that way. So my domain is like wherever, you know, all value for x, but range will be going this minus pi over 2 to pi over 2, but they're not included because these are actually asymptotes, isn't it? So they're not included, so it's a round brackets, and it's also odd function. So this is the reason. Okay, so that's not too bad. Now let's do a little bit of sketching. All right, so I'm gonna sketch y equals 3 sine, inverse sine 2x, and also y equals 3 inverse cos 2x, y equals 3 inverse tan 2x. Now number one, when we have to sketch these things, is we need to find domain and range. So step 1 is find the domain, and of course step 2 we find the range, and then remember the graph. Okay, now I'm going to show you something before we do other things. So let me see if I could get something. I don't want to write it on there because I'm going to use it. So let's have a look at this. I'm going to go, when we do y equals inverse sine x, now that's my output. I'll put something in there, and that's my input, okay, because it's inside input. Okay, so now I have new input and new output for part A. So that's my new input, output, that's my new input. So what that really means, we are going to find using input for the domain and output, which is y, which is the whole thing really, is my output. I'm going to use that for my range. Okay, so let's have a look at domain. I'm going to go, my domain was okay. So if you look at the graph, I'm just going to draw it in the box. So if we go like this, and a minus 1, 1, pi over 2, pi over 2 minus. Okay, so that's my domain for x, wasn't it? So now it's my input. New input has 2x, and we don't want this x to be our domain, we want to be x. So all you got to do is divide by 2 on it. So it'll be minus 2x half. So that's my new domain. Okay, or another way, if you think about 2x, because whole cycle going twice faster, so the domain will be halved. If you like, you can think like that. Okay, the range will be, I'm going to use my output, which will be my sine minus 1, 2x, and my output will be minus pi over 2, pi over 2. Okay, and what was my new output? There's a 3 in it. So what I'm going to do here, I'm just going to do it times by 3, times by 3, times by 3. So it'll be minus 3 pi over 2, 3 sine inverse sine 2x, 3 pi over 2, which I can replace as y. Okay, so that's my range. So I've got domain, I've got range. Now I can sketch. So let's have a look. You don't need to put it in a box, but I just want to put that in there. Oops, just going to go. So my range will be 3 pi over 2 and then minus 3 pi over 2. My domain will be minus half, half. And then that's 0. I'm going to go like that. Okay, so that's my graph for y equals 3 inverse sine 2x. Okay, so that wasn't too bad. Okay, so next one was y equals 3 inverse cos 2x. Okay, so now I need to find domain, and then I need to find range. Okay, so let's have a look. So domain, I'm going to use same 2x1, because equation was y equals 3 cos inverse cos 2x. So it'll be same. The range will be my the output will be pi over 0 pi. Be careful, because I'm going to write it again. It'll go from 0 to pi for our for cosine, isn't it? Inverse cosine. So be very, very careful. And I'm times by 3. So it'll become 0 2x 3 pi. All right, so that's my or if you want to, if it's a bit neater. Okay, so now I'm going to sketch my inverse. So okay, so I don't need to do that. This will be minus half, 0, and then it goes up to 3 pi, isn't it? And this will be half of that. So I'm going to go from here, here, here. Okay, so that's my graph. Excellent. And the next one, y equals 3 inverse tan 2x. Okay, so let's have a look at the domain and the range. So domain will be different now. It'll be, domain will be, yes, with a tan, domain will be anything, okay, all x. Now, range will be different, guys, because, let me put my output here. Don't forget that this is not included, because they're asymptotes, aren't they? So I'm going to do times by 3, times by 3, times by 3. So it'll be 3 pi over 2, 3 inverse tan 2x, 3 pi over 2. Okay, so I can rewrite this y, and that's my domain. So my sketch will be my range will be minus 3 pi over 2, 3 pi over 2. And I'll go and make sure you put the, because it's continuing. Okay, so that's my graph. Okay, well done, people.